Hey, everybody.
Hi, PJ.
Hi, Matty. Welcome to The Proactive Approach, Data-Driven Observability and Incident Response. A clever title. Follow along.
Oh, I guess I get to go first.
Yes.
So this is the part when we tell you who we are, so you can say, this is why I should totally listen to these guys, besides the fact that someone gave them a microphone or two. But anyway, my name is Matty Stratton. I'm a DevOps advocate for a company called PagerDuty. How many people here have heard of PagerDuty? Cool. How many people love getting woken up in the middle of the night by PagerDuty? It's sometimes fun, the ringtones can be cute.
He's into it.
I'm into it, right? So anyway, just a little bit of background about myself. For fun, so I also run DevOps Days Chicago, which is going to be in August, if you are into that. If you're into wanting to maybe give a talk, our CFP is open for the rest of the week. So yeah, we want to hear from you. I podcast at Arrested DevOps. I currently, for the next 2 weeks, live in San Francisco, but I'm moving back to Chicago in 2 weeks, so hence Portillo's, and Ryan Sandberg was my hero growing up. So a little bit of local Chicago flair. How many people here are from Chicago? Okay, good. So I feel good repping the hometown. If everyone was no, I don't know, I don't give a shit. I'm oh, sorry. Okay, so anyway, PJ.
So my name is PJ Hagerty. I hail from a little town just to the right of Chicago called Buffalo, New York. I am a developer advocate. I'm currently working in a company called Humio. How many people have heard of Humio? It's going to be less than PagerDuty. We know. We do logging, monitoring, observability. That's why I'm here. Beyond that, I'm a dad. I get to travel around the world, which is the best part of this job. I'm also a musician. And I tell you this because I think a lot of times we come to these conferences and we think to ourselves, oh, I'm a developer, or I'm in SysOps, or I'm in SecOps, and that's how I represent myself. But there's really so much more to you, and you need to always remember that. Also, you might be catching on, we have a little bit of a theme, so bear with us. First things first. There are going to be a lot of animated GIFs, a lot. I can't even tell you how many. We've already had one that's not even a significant percentage. I tell you this because some people aren't into that. Some people have issues and they don't want to see blinking things. I think this warning sign is much more annoying than anything we're about to show you. But nonetheless, you have been warned. Animated GIFs. And the first slide doesn't have one.
Oh, also our Twitters are at the bottom.
Oh, yeah.
They're kind of hard to read because PJ made them too little. But, and you should especially tweet at PJ a lot because he's avoiding Twitter because he hasn't watched Game of Thrones.
Because I have not watched Game of Thrones.
So
once
please,
again,
no questions about
Game of Thrones. Up to last night's episode, fine. Yeah. Anything regarding last night's episode, we will throw down. This is Chicago. People fight in this town. I've seen your hockey team. There's a kid from Buffalo on there. I know what's up. But we decided that we'd start off because not everyone comes from the DevOps background. So we'd tell you a little bit about DevOps. So it's kind of an interesting idea. It kind of was born out of the Agile framework, the Agile concept, the philosophy there. And the idea is this constant, continuous movement between the development and the ops sides. The idea here is that if you keep it moving, you keep it fresh, you can keep it stable and build much more resilient and much better frameworks, much better applications, and have much better infrastructure. And what we're going to talk about deals with all of those things, but we need to define a few things first. So the next big term, also in the title, observability. According to Rudolph Kalman, and I'm going to read this straight off the text, he coined the phrase observability, and this was his definition. Observability is the measure of how well internal states of a system can be inferred from knowledge of its external outputs. Clearly, this definition was developed from some understanding of engineering or some sort of complex system that was not what we are developing, not what we call engineering. This is about machines and being able to look at a car, hear a noise, and say, it's the carburetor. That's not totally, it doesn't really fit exactly what we do with DevOps. So we're going to kind of re-examine that and look at it more as we go through this talk. We're going to redefine observability for what we do and for our needs. Another piece of the puzzle that we need to define is the concept of an SRE. Does everyone know what an SRE is? That's fine. Don't be shy. SRE is a site reliability engineer. I've also heard there's a few people now using this term as site resilience engineer. I don't know why that's so great, but this is a person or team of people. There could be more than one. And they're responsible for kind of taking all these observed behaviors that we're getting from our feedback loop, which we'll talk about, and taking action. And that could be anything from solving problems proactively, looking at things like chaos engineering, buffing the infrastructure to make sure it can handle the load, Even dealing with something reactively, like something like fighting a fire or dealing with an outage, or finding out that something was released for production on a Friday and the engineers left at 3 because it was beer o'clock, and they decided that the deploy was good and seemed stable and everything went down, and now your weekend is ruined. And Matt's wonderful software has let you know that it's 3 a.m. and hey, PagerDuty. What else do we need to find? I'm sure everybody kind of understands the idea of the feedback loop, right? So this is the idea that information goes out, information comes back in. It's one of the most important concepts in DevOps. The ability to keep moving forward based on the feedback that we've taken in, and to change the process itself based on what we've been informed about. This is kind of the way that we understand what we need to do, and it's a major part of the entire proactive programming concept that I'll touch on a little bit. And we'll look into more like the tools and stuff like that later, but it's good to know the term feedback loop and kind of internalize that before moving forward. What do we have next? The feedback loop itself. So we know that it's key to what we do because, like I said, it informs what we're doing and it changes our behaviors. And this is great, especially like in the way that we mostly program and build systems, which is reactively. I think we can all agree that reaction is kind of the way that things function on a day-to-day basis. No one says, I know exactly how this is going to work. I know exactly what's going to happen moving forward. That's exactly how I'll code it. I don't need to write tests. Even testing, even QA, things like that are part of reactive programming because you've done something, you've pushed it out, and maybe it comes back to you before it makes production, but you're still programming reactively based on that feedback loop. People use a lot of different tools for this. There's QA tools like Selenium and things like that. Some people use actual human testers. Some people have user testing that they have a certain group that gets different features. And if you're into the whole feature flag idea, you came to the wrong talk. Another piece of this puzzle, though, is the concept of this chaos engineering that I mentioned. And if you've never heard of that, here's the quick primer on chaos engineering. The concept here is testing systems live and in production. How many people have heard of chaos engineering before? Okay, how many people feel that they actively use chaos engineering in their organization? How many people feel like there's no way in hell they could ever convince anyone at a level higher than the guy sitting next to them that they would be able to do chaos engineering? Right, exactly. So the idea here is to build sustainability and reliability through active chaos. And what this really provides is a way to get a glimpse of what's happening when the worst occurs. It's great that you might have a plan, and Matty's going to get into this a lot more. You have a plan of what to do when the shit hits the fan. But what about practicing for when it actually happens? What about making that happen live and in production and seeing what happens? This is a term that came out of Netflix. A lot of people know that. One of the biggest things that they did when they were kind of working on chaos engineering and working on the understanding of it was they actually took down 50% of their production servers live to see how many people would notice. And how many people do you think noticed? 0. And they were amazed. They were like, so we could actually have this go down and people will just be like, oh, I can't get my movie. Let me reload the screen. And they got it back up in time that people never noticed because instances were spun up. It wasn't a problem. So knowing how things get handled is not only about the application, but it's also about the infrastructure, your team of engineers, understanding where the flaws are and where the strengths might be. So building the application to deal with something like that. The next key feature to the feedback loop is proactive programming. Which is part of the observability. This is the direct feedback that you get from your application, infrastructure, all the other systems that allow you to actually deploy a thing into the world and make sure it's functioning. There was a time when folks would write code with no tests, no QA, no staging server, no sandbox. That time is in the past. And this is coming from a person, I used to be what they called a cowboy coder. Which I would just literally rip code and just be like, there we go, I made it. Let's put it into production. And people would be like, what if it's broken? I'd be like, screw it, who cares? That was the way it was. And this is not like, I'm not talking about the faraway past, like this was in the 90s and people were on bulletin board systems and modems were hilarious. This is like 2 weeks ago. There's still people that are resistant to the concepts of QA and testing and having a feedback loop. They're just like, just write it. Luckily, we have things today like Travis CI, Go CD, these things that allow us to prevent ourselves from doing the most harm before it ever gets to production. So this is like pre-chaos engineering, making sure that we don't screw it up before we can screw it up. So let's look a little bit further into observability. So monitoring methods and tools far and wide. They're getting more sophisticated than they used to. How many people have used like New Relic? New Relic is like, it's an APM, like it's a good application monitoring system, very high level, lets you know kind of what's going on more or less with your application. It doesn't give you like a lot of insight into your distributed system or your infrastructure at all, really. And our infrastructure is getting more and more complex as time goes on. This is why you end up needing things like PagerDuty, because things aren't going to be smooth running. You don't have that cool server in the closet that's hooked up to like, 4 nodes and there's wires hanging from the ceiling and it's really sweaty and hot. That's not the way the world works anymore. We're working in the cloud, or we have our own server farm, or things are gigantic. And it's crazy. So actually being able to monitor and see those things has really changed the way that we're able to deal with them. And then we start looking at things, and this is the big concept, in real time. I will say this. I work for Humio. We're a pretty awesome company. We monitor things. We have less than 1 second latency, which is absolutely fantastic. Real time, though, would be instant, and that's as near to impossible as you're going to get. Lots of other systems, you're not seeing feedback for 5 to 10 minutes. That's no good. How do you react when everything's already gone wrong and the phone's already ringing and your emails are filling up because your system is down? So you want to get that time to as low as possible. You want to be able to view information, investigate it, figure out the behaviors, and fix it as quickly as possible to understand what went wrong and deal with that. And Matty's going to touch on that a little bit more. But real time, it's a critical concept. It's a critical idea when it comes to application development and monitoring. Most tools, they focus on digesting the information and kicking it back. That's not really what we're looking for. We want something as near as instantaneous as possible. We can get the full picture of this without making all of the aspects of what we're trying to observe readily available. So it's kind of like the whole idea of like, a JIT compiler. It's just in time. We want to see the things that we need to see at the time that we need to see them. We don't need to see everything all the time. If that was the case, you wouldn't need a monitoring tool. You could just look at the logs and enjoy the rest of your life. If you're into that, that's cool. But up to this point, we've had to deal with things like slow query speeds and latency and ingest to search, making data not available and data being dropped. Things have luckily, because of the DevOps concept, gotten a lot easier in the world of observability. Because of the ideas of site reliability and stability in the application, that translates to the applications that are monitoring your infrastructure and your applications. They need to be just as reliable so you know that you can trust them. This ultimately results in outdated observability. Like I'm talking about the things that were in the past. So when you're looking at just parts of the system, like let's say you're looking at CPU, and that's kind of where your obsession lies. You want to make sure that the CPU doesn't get overridden and your instances don't have to auto scale. That's great, but if the issue is your CPU is going up because you have a flop issue, but you're not looking at flop, then you have a problem because you're not seeing what you need to see. And that's observability is all about seeing what you need to see. So data-driven observability means that you leverage all of your log data and use real-time streaming compatibilities for querying and dashboards so you can power live systems that has visibility for engineers, visibility for the ops team, and visibility for like the ops-minded DevOps folks, such as yourselves now, because I gave you the definition, so now you're all DevOps experts. Mm-hmm. We can get a stamp, we can put it on your badge, it'll be awesome.
Update your LinkedIn, it's good.
Update your LinkedIn, I will endorse you. So making systems better is the real goal of observability teams. Like the more we know, the more we're able to improve and adjust what we're doing. It's commonly said that software development is never finished. Does anybody ever think they've ever written anything that was done? And I mean in software. Do you really?
I wrote drivers.
Yeah. Okay, different situation. I'm talking about, yeah, I didn't say that. I didn't say that. That was you. Quote him. What's your Twitter? Anyway, but the idea of being done, it kind of works the same way with observability. You're never going to stop looking at your system. You're never going to stop trying to see what's going on, because as soon as you turn your back, everything's going to go wrong. So we're trying to eliminate some of those elements of surprise and make our application environments easier to manage and easier to use. So remember not to get too caught up in the tooling. Find a simple thing that's not always the best or the longest running. Humio is new and easy to use, by the way. Use the thing that allows you to see the most that you need to see out of your system, and that helps you to become a proactive programmer. Live system observability is all about being data-driven, and that's really what we should be looking at when we're trying to worry about observability and worry about our infrastructure, our application, what we're building, what we're doing. And it improves the overall health and resiliency of your systems, and to be perfectly honest, it improves the overall mental health and reliability of your teams. If they're able to see what they need to see when they need to see it, then they're not stressed out about getting called at 3 a.m. because everything's breaking and everything's on fire. Mitigating the whole idea of live system observability is a top of the heap for every modern company and organization developing an application. Whether it's a web application, mobile application, whether it's drivers, you still need to monitor these things. So you need to give you need to give your developers the tools they need to be successful, and observability falls into that. So find out what works for you, use the tools that work and work for everybody, and go forward. Observability, the interesting thing is it comes to almost every single part of the DevOps cycle. Like, yeah, maybe not when you're strictly writing code before it even gets pushed, you need to worry about observability. But once it's built, once it's released, deployed, it's in operation, once it's being monitored, once you're developing your new plan, you use the information from what you've learned from that last deploy to say, okay, well maybe having 8,000 extra lines of node to make snow fall prettily on the screen is not such a great idea. That's literally, I heard that story last night. A friend of mine was talking about he had built a site internally at Microsoft that at Christmas time it started to snow with a nice JavaScript thing. And the problem was every single piece of snow was 2 pixels. This was 10 years ago. Every single piece of snow was 2 pixels, and it would fill up at the bottom of the screen slowly over time, crashing the site every 5 minutes or so. It was an internal site, and lots of people at Microsoft sales used it. He crashed it and then went on vacation. I'm pretty sure they were using PagerDuty at the time or something very similar, because he got called back in pretty quickly. But it's really about the several different parts of the DevOps cycle coming together. You want to be able to see what's going on at all times, and that's the key. It's a major part of DevOps. I've mentioned this a couple times. Part of this observability concept is also having a proactive programming approach. To be clear, some people have heard this, and I've done a whole other talk about proactive programming, and they've heard this and been like, proactive programming, so like having the ability to see in the future exactly what your code's going to do once it's out in the world. And like, that is not even close to the definition. The idea is using your tools to eliminate as many of those problems before they ever become problems. And problems can range to everything from a script that doesn't exactly run properly and starts to build up all kinds of CPU and infrastructure problems because it wasn't properly metered. Or it could mean the person who didn't run their test code somehow went beyond the CI/CD situation and released to production. Problems can be human too. Observability works there. The idea behind proactive programming is pushing the concept of isolating variables that might be easy to mitigate. And we'll take a look at some of these things as we move on. Again, this is not being the all-knowing mastermind, awesome person that you are. But, it's nice to get that gig if you can. And if you can, I'm sure you're doing like John Edward talks, or you're on The View or something talking about how you can see the future. Being proactive just means taking into account that there's considerable work to be done first to establish a base for handling user issues or code issues. The initial code doesn't solve problems. Rather, it sets up the organization to be necessary to be able to do that in the future. So this doesn't mean that you're giving up on the flexibility or that you have to have some sort of rigid structure to the way you do things. It's still iterative. You're still going to use the iterative nature that you use in programming, or should be if you're using modern programming techniques. But what it does mean is you'll have a nice toolkit to plug the holes and patch the leaks before they happen. So kind of think of it as, instead of using Spackle and WD-40 and Flex Tape, Flex Seal, I don't work for those companies. But instead of using that, you actually have some things that are going to make sure the gutters aren't leaking before you put them on the house. And that's kind of where it comes. It's kind of like building a house. You want to start with a strong foundation. When you build your code, you want it to be, not brittle. You want to make sure it's secure. You want to make sure the site or application is going to be reliable before you start to build on that foundation. If you're going to build on popsicle sticks and duct tape because you heard about this cool new open source language that everyone should be using, you're going to have problems. Because if it's not mature and it's not ready and your team isn't able to build something that's got a good foundation, it's going to fall over. You wouldn't build a house and leave out the roof. You wouldn't build a house and leave out the foundation and the structural beams. You're not going to do the same thing with your code. And that's what proactive programming is really about. Making sure that anything that goes on top of the stack is going to be stabilized by the things that are beneath it. You want to solve matters kind of before they become an issue. You generally spend more time on optimizations, for example, improved security or caching of everything for people to use the site offline if necessary. It's about developing more stable situations. But you could anticipate kind of the wrong future and end up with something that spends a lot of time that isn't important. So you don't want to like mire yourself in making sure the structure is so stable that it can't be broken. You don't want to make the most secure system in the world. You want to try, you want to make your best effort, but don't get kind of mired in the yak shaving and trying to build things that aren't going to be stable along the way because now you can't actually work outside of this box. When it comes to proactive engineering, the focus is on being as safe and secure as you possibly can. And you do this before putting things out into the world. So this means having a tight feedback loop. The key drawback to proactive development is it will take more time in the initial stages. And this is where the hard sell comes with the people who are ahead of you and the director and the C-suite folks. You're going to say, listen, I want to make things as stable as possible, and it's going to take a little more time. And they're going to be like, no, get this out. And it takes time to have an understanding. It's a cultural change to bring in proactive programming. And that's fine. Understand that you'll need to take that time. I have a little anecdote about that. I once worked at an academic software company. That sounds about as sexy as it was. Everything was beige, but it was really fun. We had a lot of fun solving problems, but we decided to port it from Visual Fox Pro. How many people remember Visual Fox Pro? I am so sorry. I apologize immediately. But we were porting from Visual Fox Pro that was generating weird dynamic ASP pages to Ruby on Rails. And the project had originally been built over a course of 3 years, and they said, cool, you've got 3 months to convert it to Rails. And we were like, cool, it's not going to work. And they're like, great, just do it as fast as you can. And we're like, well, we have to write the tests first. And they're like, oh, no. We don't have time for writing tests. I was like, but this is the way you do like Rails. This is like built into the system. They want tests. They're like, no, you don't have time. So, of course, we released January 1, and the big educational foundation that we were doing this for found that the whole thing was broken and like students were being dropped from the database randomly. And we manually backdated everything and put people back into the database. And they were like, what happened? How did this happen? Like, we didn't write tests. If we had been using some proactive programming techniques, the tests would have been written, the software would have been stable, we wouldn't have had that problem. 3 months may not have been enough time. So all of it together, the feedback loop, observability, proactive programming, they're meant to make your team more resilient. So while your title might not be site reliability engineer, you are part of the site reliability engineering focus, the site reliability engineering ideal. The honest truth, nothing will make you 100% bulletproof. That's not the way the world works. And I'm sorry that I had to be the one to break that to you. I'm sure this is a rough talk. I'm sorry. So what happens when it all goes sideways? So this is the point where I will hand it over to Matty, who will tell you exactly how that works. Oh, the other one, yeah. That's important.
So one thing, thinking about observability that always comes to mind, especially when PJ was talking about not having the predictability, is it bears to mind when I was working for an e-commerce company here in Chicago, and if you kind of look me up on LinkedIn, you'll figure it out. It might be a place where maybe you want to rent a thing. Sometimes you go and look, and we would take an outage, and my boss would come to me and say, how come we didn't have monitoring in place about that thing? And I'd be like, because we didn't know that was a thing that could happen until now. And this is where it comes in. So monitoring and dashboards are all ways to reflect on what you actually already know. Observability helps us answer questions that we didn't know that we had. And so when we kind of think about when things go wrong, so we think about incident response. So we talk a lot about incidents. If we are in kind of a ITIL, ITSM world, there's a formal definition, and you can read a bunch of books, and yeah, I've taken the training, and it's a bunch of horse crap. But whatever you want to call it. But the thing is, when we talk about incident response, it's just like PJ said, it's when something is happening that isn't what's expected. Something is causing our business to not be able to do the things that make our business happy. And we need to be able to restore service. It's really all about interruption and service. But here's the thing. Incident response depends on what matters to your business. So this happens to be the definition of an incident that we use at PagerDuty. It's not the one you have to use if you use our product. It's the one that we use because we are a product. And as it turns out, people kind of care if we're available. So we define an incident as any unplanned disruption or degradation of service that is actively affecting customers' ability to use the product. Should you use this definition? I don't know, if you want, if it works for you. But here's what matters. You have to have a definition of what an incident is. Because if you don't know if an incident is happening, you don't know if you should respond to it. So what matters about a definition of an incident is it needs to be relatively simple, So it's easy for everybody in the organization to remember, and it needs to be widely publicized. So there's no argument. There's no rules lawyering about was this really an incident or not. Now there's more granularity that might come into play. So like a typo would fit into this definition for us. So does the whole site being down. So we get into more granularity around severities and things like that. But it's really, really important to have a clear definition of an incident because that's what is going to trigger your incident response process. Now, in the incident response process, one of the most important things is we have to change our mode of thinking. We have to make this mentality shift. We're creating a distinction between normal operations and there's an incident in progress. We're switching decision making from peacetime to wartime, right? This is from normal day-to-day operations to actively defending our business. And the reason this matters is there's things that might be considered completely unacceptable during normal operations, such as deploying code without running any tests. That's not acceptable during normal operations, but it might be acceptable during a major incident when we're trying to restore service quickly. So the way that you operate, your role hierarchy, and the level of risk you're willing to take all change as we make this shift, right? So remember, fire is not an emergency to the fire department. You expect rapid response from a group of professionals that are skilled in the art of solving whatever issue you're having because we're switching our mentality. Now, not everybody jams to like the military metaphor, so that's cool. You could maybe say normal and emergency if you don't like peacetime and wartime. Or if this is even too complex, you could even just say okay and not okay, right? I don't really care what you call it. You could do a happy smiley emoji and like, a fire emoji if that's what works for your organization. But what's happening is you're making this mental shift. This is probably one of the most important things about incident response because there are a lot of things that change. And one of the most important things to remember is during an incident, any energy or activity that is not directed towards restoring service is a waste. Someone's getting paged. All right, so along those lines, one thing that we feel is really, really important, and by the way, most of the quote-unquote rules I'm going to tell you about incident response are things we learned the hard way at PagerDuty. So we're not perfect. But this one is, so don't litigate severity. And what does this mean? This means that when you get on an incident response call, you don't spend time arguing about, is this really a Sev 1? I think it's a Sev 2. I'm not quite sure. And the reason is, because by the time you're done arguing about whether or not it's a Sev 1 or a Sev 2, guess what? It's a Sev 1. This has already happened. And it does not help us restore service. Because your severity levels, they might have to do with your communication process, but oftentimes what you will run into is sort of, you'll see kind of artificial parameters around things like, well, if it's a Sev 1, we attempt to restore service within 5 minutes. If it's Sev 2, we have half an hour. I'm sorry, no matter what, you're trying to restore service as quickly as possible, right? But it might have to do with with how you communicate, right? Which customers are impacted. One of the things I find when I give talks like this and I talk about this slide about don't litigate severity is I will talk to people afterwards and be like, oh yeah, that happens to us a lot. So people say, yes, we have this happen on incident calls all the time. And I will turn around and say, I have a question for you. How does your senior management measure effectiveness of your team? Oh, well, how many Sev 1s do we have this month? So what happens is when you are measuring people according to Sev 1s or things like that, like the number of high severity incidents, people don't worry about the metrics of mean time to resolution or mean time to acknowledgement. They start to focus on a metric I call mean time to innocence. So you spend most of your time proving that it's not really a Sev 1, so don't yell at me. This doesn't help anybody. So that's a lesson for management. Another thing that's really important, so the way we follow our incident response process at PagerDuty is it's heavily influenced by something called the incident command system, which is used by first responders. And there's kind of a whole history around, I guess to sort of give a little bit of background. So back in the 70s, there was a spate of very, I almost like made a state and Maine reference, which is a spate of suspicious wildfires, a spate of many wildfires in Southern California. And they brought in all these fire departments from all over the state to work together. And they had a really hard time working together because while they were all very skilled in the art of putting out fires, every department had a different way of working together. So the incident command system was created, which was a standard way for first responders and firefighters, and now FEMA uses it, and a bunch of other organizations. And one of the things that's important is that we don't necessarily use every single thing that's part of the incident command system, but one thing that's really key is there's a role called the incident commander. And the incident commander sits at the top of the incident call. And what's really important about the incident commander is they delegate and they make decisions, but they are not a resolver. They are not someone who's logging into servers and restarting services and looking at deploys, right? So they are not someone who's actually resolving the incident. They're there to help coordinate and make decisions and communicate amongst the subject matter experts, the people who are actually empowered and skilled at working at restoring service. Does the incident commander have to be a technical person? They actually do not. And one thing that's an interesting thing we found at PagerDuty is that some of our best incident commanders are product owners. And part of this is because the problem with having like an engineer or an engineering lead or an SRE be part of the incident command rotation is what happens if the incident commander, we say they're not a resolver, what if they are the person that's best equipped to actually solve the problem? Do they try to solve the problem? Well, no, because as the great Ron Swanson would say, never half-ass 2 jobs, whole-ass 1 job. So what you have to do is then you have to pass off the hat and everything. So we find that product owners actually are great incident commanders because number one, they're not going to be tempted to try to solve the problem. Number two, they tend to have skills that are really good at being an incident commander. They're good at delegating, they're good at decision making. And an additional bonus that happens is when your product owners are actually on call, they suddenly care a lot more about reliability, and a lot of those technical stories suddenly manage to make their way up through the backlog. But that's just kind of a nice extra bonus of that. So again, the incident commander is not a resolver. This is also a tricky one. The incident commander is the highest ranking person on the incident call, no matter what their normal role. No matter if they're just normally an individual contributor, another form of IC, an engineer, they could be a QA person, they could be a product owner, it doesn't matter what their normal role is in the org chart. On the incident command, on the incident bridge, they are the highest ranking person, even higher than the CEO. This is tricky, but it's very, very important for effective incident command because the incident commander has to not be second guessing and feeling like that. Do not surprise your executives with this. Socialize this before you start bringing it into practice because it will not go well for you. Kind of a history, this happened at PagerDuty. So our CEO, when she was new, maybe about a month or so into her tenure, we had a major incident. And she got on the call and started barking orders. And the incident commander, who was an individual contributor engineer, said, "Jen, you're being disruptive. I'm going to have to ask you to leave the call." And she did, and she got really mad. And then our VP of engineering and everybody kind of explained afterwards, like, "Jen, this is why we do things the way that we do." And now she completely understands it and helps espouse it. But it's usually a good idea to socialize this before. And this leads into another thing that can happen during an incident call, which is something that we call executive swoop. So the executive swoop is when you might get a senior management, somebody gets on the call and says something like, for example, "I want this incident solved within the next 10 minutes. How many people have ever had that happen to them, right? Okay, so not only is this incredibly demotivating because it's implying that everybody was not already working as hard as they could until the CEO got in there and yelled at them, it doesn't actually help because everyone's trying to do their best. And one of the things as the incident commander, because this can be really hard, right, when this happens, because you're like, well, it's a CEO, it's a CTO, this is my boss's boss's boss. What do I do? If you are in that position and you're incident commander and the CEO or someone gets in and starts barking orders, there's a very easy way to handle this. And here's the pro tip. You say, "PJ, are you taking command?" Yes. Well, actually, what will happen is 99% of the time, you will say nothing.
No.
Or say no. Because number one, if they do say yes, fantastic, great. You're now the incident commander, and I'm done. But usually they will not want to take command. And what's happening is also giving that executive a chance to save face, right? Because they want to do the right thing. This is their business too. Another form of executive swoop that I think we probably all may have heard is they can come in and say, "I need a list of all the affected customers right now." All right, how many times have we heard that one? So what you say as the incident commander is you simply say, "We can either do that or we can restore service. Our focus is on restoring service." You notice I didn't say, "Which do you want me to do?" Just telling you, this is what we're doing. So there's a bunch of tricks, and we'll talk. I'll point you out at the end of this talk to how you can see our whole incident response process and training, and we go into a whole bunch of other ways of dealing with executive swoop. But this goes back to, remember when I said we do a mentality shift. So we are much more direct in how we communicate. We are doing less, making sure everybody feels good about everything, because we need to restore service. And sometimes that means putting executives in their place. Now, one of the ways you can help with executive swoop is by making sure you have a good mechanism for notifying stakeholders. Something outside of the incident response call itself. Because how many times do we run into this? Every 5 minutes, you've got some other executive jumping on the call saying, somebody bring me up to speed. And now we all have to stop what we're doing and bring you up to speed. So we need to have some kind of a mechanism, and that could be a separate, like a PagerDuty, we have 2 different Slack channels we run during an incident. We have one which is the war room for the people doing the work, and then we have one that's a notification. And so our incident commander, in conjunction with our communication liaison, notifies stakeholders that way. So they have a way to know what's going on without actually having to get on the bridge and be disruptive. So having a mechanism to notify your stakeholders is an absolutely key piece of that. So how do we actually go and resolve the issue, right? How do we do this? We said we have an incident commander, they don't resolve things, they have their subject matter experts. So how do we go through? And the way we do is with this mechanism we call sizing up. Because again, remember, the incident commander is the one who's going to be making these decisions, but they don't have all the information. So you go to your subject matter experts, the people who were brought in on the call, who are your SREs maybe, the application folks who support that particular system, your DBREs, whoever it might be. And you say, first of all, what do we know? What are the symptoms? Get this information. Then you ask and you say, what can we do? And the important thing is the question I'm asking there is not what should we do, what can we do, right? So tell me my options. And then I'm going to follow up and I'm going to ask, what are the risks? So now I, as the incident commander, have all the information I need to be able to assign an action, right? And that's kind of a key thing. You notice I'll say that we assign an action. And when we assign an action, one thing to watch out for, one of the most deadly phrases during incident response is can someone, right? So I want to say, can someone go look at the firewall logs? I will say, PJ, I want you to go look at the firewall logs and see if there was any intrusion in the last 30 minutes. I will check back with you in 5 minutes. Understood?
Yep.
Understood, right? So what happened there is it was assigned to a specific person, it was time boxed, and I made sure that PJ understood what I was asking him to do. Now, if I come back to PJ in 5 minutes and he doesn't have any more information, do I go back and say, I will check in with you in another 5 minutes? At this point, no, I say, how much more time do you need? But again, the whole point is it's still time boxed, it's still assigned to specific people. And now we talk about actually making these decisions. Because again, the incident commander is the one who's making the decision, but they're not making it in a vacuum. We do have all of our subject matter experts there. And what we want to do is we want to have a very effective and efficient mechanism for making these decisions and getting the information we need. So for example, I propose that this background is blue. Does everyone agree? Do you agree? Do you agree? PJ, do you agree? Joe, do you agree? Do you agree? Okay, I don't have time for this, right? So let's try this a different way, right? This takes a long time to reach consensus if I'm going to ask everybody. Distributed consensus is really hard, both when it comes to people and when it comes to systems, like Raft, right? So we forever trying to argue. So we tried a different way. I propose this background is blue. Are there any strong objections? Hearing none, the background is blue, let us proceed. So the key phrase there is, are there any strong objections? And you need to use the phrase exactly like that. Because, number one, we're optimizing for the 99%, right? So we're saying, are there any objections? But I don't just say, are there any objections? I say, are there any strong objections? Because, again, remember, during incident response, we're doing a mentality shift. We're not necessarily looking for the most optimal solution. So you may have an objection, but it's not strong. You don't feel strongly about it. You're like, I'm not so sure that's great, but it's okay. So that's a real important key about that. And what this also helps us avoid is hindsight bias, which is the thing later on when someone can say, well, if you just asked me, I would have told you not to do that, right? This is giving the opportunity to raise these objections. This is another one I feel really, really strongly about, and this is because I've worked for a lot of large financial and insurance institutions, as one does when one has spent 20 years working in operations in Chicago. So how many people have done incident response at one point or another in their career, been on call, tried to troubleshoot problems, been on these terrible bridges? Okay, how many people have been on a bridge where there's like 100 people on the bridge, right? Okay, so this is super stressful, and this happens a lot in large organizations because they're like, let's get everybody we can think of who might possibly be able to help. Let's get them all on the call. And what ends up happening is you've got 100 people on the call, 5 of whom are doing any work, which means we have 95 people there doing nothing. So they're getting super stressed out and pissed off because they're like, I'm sitting here waiting for those 5 developers to go and check their deploy and roll back their deploy. By the way, it's 2 in the morning and I'm super tired and I don't want to be here. But it's also incredibly stressful for those 5 people because they know there's 95 people sitting around waiting them to do something, right? So it's in addition to adding the stress, it's financially expensive because let's assume each of those people is costing you $100 an hour. That's a very expensive bridge to be on. And it's expensive in terms of time. If it's happening at 2 in the morning, all these people are not going to be very fresh the next day. And we should also, hopefully be humane to our coworkers. But, if you don't care about that, but you care about the money super matters. So we like to say rally fast, disband faster, which means get the people. It's easy to get people on the call, but give them the opportunity to drop. When you sit and say, okay, you know what? It looks like right now we need to have database reliability engineering working on this. So anybody who's not DBRE, feel free to drop off the call. We will page you if we need you. It is much, much better for your psychological safety to be able to say okay, I can drop off the bridge. I've got my phone on me. They will call me if they need. You can get these people back. And this is a really, really huge thing to help make on-call much more humane. And probably one of the best bits of advice is don't panic, right? So everything about being on call is designed to raise your adrenaline. Just sort of the actual, hearing that PagerDuty alert makes you go, whoo, right? How many people are sitting there on the train and somebody's got their text tone set to the same thing that your incident response comes to. And somebody gets a text and you're like, oh, I hate you, right? By the way, little pro tip, I recommend rotating your alert sound for your on-call regularly because that will help you not have this physiological response that gets embedded in you. But the point is, now, you can't keep yourself from feeling this way, right? We can't make ourselves not feel a certain way, but we can control our response. And the thing about this is that if we show panic is contagious and will make the other responders that we're working with, they will start to freak out as well. Remember, fire is not an emergency to the fire department. And when we were putting together our incident response process at PagerDuty, some of our folks trained with actual firefighters, about the process. They didn't go learn how to put out fires, but that would be kind of cool. And one of the things that some firefighters told them is they said, it's not uncommon. They'd be called into a house fire, and the homeowner is, logically and rationally freaking out because their house is burning down. As would happen. If your house is burning down, you're probably not cool as a cucumber. And the problem is this panicking homeowner is actually getting in the way of the fire department, right? It's making it hard for them to do their job. So what they would say is, hey, this may be your first fire, but it's not our first fire. And one of the things that can really help with this is when PJ was talking about chaos engineering. So if you think about doing failure injection, so we do our game days. So at PagerDuty, we do something we call Failure Fridays. And this is every Friday, we take a certain part of our system, and we intentionally inject failure into it, right? And it's our way of performing chaos engineering and saying okay, let's see what the system does and understand that. We run it like an actual incident, right? The upshot is we know what's wrong because we broke it, but we have an incident commander and we run our whole process. And this does a couple really great things for us. Number one, it's great training for incident commanders. So before you go on call as an incident commander at PagerDuty, you have to have run a Failure Friday because it's a safe place to do that. The other thing is it gives us the opportunity to practice our incident response in a predicted, calm, understood mechanism. So we create this kind of physiological muscle memory, if you will. So when it happens at 2 in the morning, we're like, hey, you know what? This process doesn't raise my blood pressure because I'm used to doing this. I know how to get into the Slack team. I know how to get into PagerDuty. I know how our call works. I know how sizing up works. We do this all the time. Fire is not an emergency to the fire department. Now, we've actually restored service. So hurrah, great. So now we can all just jump off the call and go back about our business, right? Unfortunately, there's a couple things we need to do before we're done. And one of the most important things that has to happen before we're done is the post-mortem or post-incident review or after-action report, whatever the heck you want to call it, I don't really care. That thing you do afterwards has to be assigned to someone, and it has to be assigned to a person. Now, it doesn't mean that this person is the one who's responsible for writing it all, but this is saying the post-mortem is owned by PJ. So we know who's going to be setting up the meeting, who's going to be starting to put the template together, collecting all the information, and it is usually not the incident commander, but the incident commander is responsible for making sure it gets assigned to somebody. And it's really important to make sure that you do that before the end of the call. So speaking of which, so we talk about postmortems. How many people are familiar, have heard about the term a blameless postmortem? Okay. So if you haven't, Google it. John Allspaw wrote a great blog post for Etsy's Code is Craft back in 2012. The idea, though, is that when we're looking at these, we're looking for what happened in the system, right? We're not looking for who do we fire. So we talk about having a culture of blamelessness because you know what? People are going to make mistakes. And if people are afraid of being punished for making mistakes, this does not make them make fewer mistakes. It makes people become subject matter experts in hiding their mistakes. And now you are well and truly screwed because you have no idea what's actually happening in your environment. So the thing is, when it comes to postmortems, blameless is really, really important, but it's just the beginning, right? They need to be, I like to say they need to be useful. And what that means is postmortems should not be a form you fill out like you're doing your taxes, right? It's great to have tools like PagerDuty or have something in Google Docs, have a template, that's great. The problem with stuff like that is, just like we talked about that observability helps you answer questions you didn't know to ask. A postmortem template is only going to have you answer the questions you've thought to ask. So postmortems should ask more questions than they answer. And a template can help you with that for sure. But you also want to make sure you tell these stories. You communicate them. And I'm giving a talk tomorrow called Releasing Organizational Trauma, and I talk about why this is important, so that's a little plug for my talk tomorrow. The other thing that matters is you want to communicate, these things need to be communicated outside of just the team that was affected. So J. Paul Reed wrote his dissertation on postmortems. And one of the interesting things that he discovered was that the larger the organization, the less likely teams were to share their postmortems outside of their team. The irony is the larger the organization, the more important it is to share that information outside of the team because systems are interconnected. Sorry, not sorry. Nobody works in a silo. Everything, and also people. There's diversity of thought. People will on other teams will think of things that you didn't necessarily think to ask those questions. Those questions will help you answer things. So as I said, we have open sourced our incident response process at PagerDuty. So if you'd like to learn more about it, you can find it at response.pagerduty.com. There's a link to it. It's on GitHub, so you can fork it, build your own process. Should you use our exact process? Absolutely not. You are not PagerDuty. You're a bank. You're apartments.com. You're Humio or whatever. You're whatever you are. Whatever it is Joe does. But there are places to start and places to understand. And we also do take pull requests because we are continually learning. So we'd always like to hear more about that. And I know that PJ and I are the people standing between you and happy hour, but we do have a couple of minutes. If anybody has any questions about either the observability that PJ talked about or incident response practices, we're happy to answer your questions and talk about it.